we'll start here now with just a review of efficiency before we get into the last couple of examples that you need to finish off. So remember from a previous class, we had said that efficiency is the work done by a system divided by the work done on the system. Really, what that means here, if we go back to the previous example, we had a box that we want to lift to the back of a moving truck. And in order just to lift the box straight up, if the box weighed 500 kilograms, it would take 3,700 joules of work to lift the box directly. And figuring that was too much for the average person to do, we would use a pulley system. Sorry, not pulley, but a ramp system to do it, as shown here. Sorry, down there. And in order to use a ramp, we figured that it would take roughly 3,900 joules in order to use a ramp to lift the box. And here. So now to look at efficiency from that, this is work that we would have to do. The minimum amount of work that it would take if you could lift it is 3,700 or 3,675. So how efficient is the ramp? Well, the minimum work that's required, the work out of the system, is 3,675. The work that we would have to put into it is 3,900. So you divide the work out, divide by the work in, and it's 94% efficient. We then looked at this example. If you got a quad that weighs 2,400 newtons, and you want to put that quad to the back of your truck, so it has to go up 0.6 meters, what's the efficiency? Or first we figure out how much work is required. So the work out is how much work is required if we don't do anything to help ourselves. So the work out is force times distance. So we know it takes 2,400 newtons. That's the mass of the quad. It has to be lifted 0.6 of a meter. So it's going to take 1,470 joules. Now if we decide to use a plank to drive the quad onto the truck, the amount of work it takes to move the quad up the plank, or amount of force, is 625 newtons. That's got to be put over 2.5 meters. That's the length of the plank. So it would take, to use the plank, 1,560 joules. So the work to use a system to help us, when we use a system, pulleys, planks, levers, that always requires more work compared to just doing it without the system. The problem is that you can't do this on your own, though, that you couldn't just lift a quad, so you have to use the system. So how efficient is it? Again, it's how much it would take without using the system compared to how much it takes when you use the system. So this is without using any assistance, and this is with assistance. And it's 94% efficient. Okay, I'll end it there, and in the next video we'll look at a couple of extra examples.